This video is going to cover derivative applications, section 11.4, and one of the first applications of the derivative is to find the equation of the tangent line and another line that we'll call the normal line, which we'll talk about a little bit further down in this lesson. Recall the derivative of a function at a given point, that point would be x, f of x, represents the slope of the tangent line to the curve at that point x comma f of x. And what we're going to do is we're going to take the derivative at a particular point in time, identify its slope, and using the coordinate where we're taking the tangent at and that slope, we're going to develop the equation of the actual tangent line. So what I had you start with just in class is I gave you two functions, f of x equal x squared and f of x equal x squared minus 8. And I asked you to think about what the derivative would be of each of these functions at a value of x equals 2. Well, it turns out on the function x squared, that would be at the point 2, 4. At the function g of x squared minus 8, we'd be taking the derivative at the point 2 comma negative 4. And if we wanted to make each of these tangent lines have a slope of 2, they'd be something like this. Obviously, they'd be different lines. They're both tangent lines. I just don't have enough room on pencil with my thick thumbs here to show that. But both of them would have slopes of 2, but they would certainly be in different locations. Why? Because the underlying points that they're tangent to are in different points, different locations as well. So, if we do a little bit of work here, let's go back to our original equation, we can go ahead and start to build some of those tangent line equations. Find the equation of the tangent line to the function g of x squared minus 8, where x equals 2. Well, to do this, we need to compute the derivative g prime of x, which in this case is nothing more than 2x. Where do we need to evaluate the derivative? Remember, the derivative is the slope of the tangent line all over the place at all the different locations that you can have an x coordinate. Wherever your x value is, 2x will happen to be the slope of the tangent line to the curve of this function. And so, if x is equal to 2, g prime of 2 is going to be equal to 2 times 2 are 4. Now again, we know that the point where x equals 2 on the original function is 2, negative 4. So remember, g of 2 equals negative 4. And so the equation of the tangent line translates into nothing more than this. Find the equation of a line with slope of 4 that connects or touches or goes through, that's the better language to use, it goes through the point 2, negative 4. That's what we're being asked to do. When x equals 2, our derivative takes on a value of 2x, 2 times 2, because x equals 2. Our derivative is equal to 4 at the point 2, comma, negative 4. What's therefore the equation of the line with a slope of 4 that goes through the point 2, negative 4? Well, working with slope-intercept form, and again, since I don't have a lot of real estate, I'll do the following. I'm going to say, y equals 4x plus b. That's what we'd be working to solve in this case. I know that y is negative 4. I know that we have negative 4 is equal to 4 times, our x value is 2, plus b. I'd have negative 4 equals 8 plus b. Negative 4 minus 8 equals b. b equals negative 12. And our final equation, that the tangent line to the curve, g of x equal x squared minus 8, where x equals 2, the equation of that tangent line is nothing more than 4x minus 12. That's our final equation. So let's do just a couple more practice points. New function, f of x equals 3x cubed plus 2x squared. Find the equation of the tangent line to the function f of x at the point 1, comma 5. So I already know the point that my tangent line needs to touch. Knowing a point, if I can get the slope of the tangent line At this point, I'm going to be in business. What do I know? F of x equals 3x cubed plus 2x squared. F prime of x equals 9x squared plus 4x. What do I need to have? My tangent line has to exist where x equals 1. Here's the tangent line equation. The value of the tangent, let me rephrase that. Derivative will be the value of the tangent. I'm going to compute f prime, the derivative at x equals 1. 9 times 1 squared, 9, plus 4 times 1 plus 4 equals 13. What do I know about my tangent line? It has a slope of 13, and it touches the point 1, 5. Slope 13 through 1, 5. And again, I'm just going to use slope-intercept form. 5 equals 13 times x, which is 1, plus b. I'm going to walk into, in this case, 5 equals 13 plus b. 5 minus 13 equals b. B equal negative x. My tangent line equation becomes y equals 13x minus 8. That is the equation of the tangent line to the curve f of x equals 3x cubed plus 2x squared at the point 1, 5. So I hope this gives you a good start. There's an interesting example of how we can use the slope of a tangent line or the equation of a tangent line to maybe estimate some values on an original function. This is in the book. I'm going to bypass it for the purposes right now and just talk about one more concept, the equation of the normal. Finding the tangent line equation, again, is a very common calculus application. And another concept that you'll hear about occasionally, you'll see this in physics, you'll see it in other places, is you'll hear about a line that is called a normal. And by definition, a normal is a perpendicular. A line that is normal to something is perpendicular to that thing. And so we're going to start doing some work where we're going to go ahead and compute our tangent line at a particular point, just like we did the tangent line equation at 1, 5 for this function f of x. And we're going to also compute the equation of a normal line. You're going to see there's importance. The value of perpendicular lines comes over in many places in calculus down the road. And so this concept of grabbing a normal is a very common thing. Bottom line, write the following. Normal, perpendicular to tangent. Your normal line is perpendicular to your tangent line. So let's work a couple examples that we see here. Find the equation of the normal to the curve g of x equal x squared minus 8 at the point 2, negative 4. So we're kind of using something we did on the first page. Again, g prime of x equals 2x, g prime of 2, because I need to know the slope of the tangent line when the x coordinate is equal to 2. G prime of 2 equals, we did this before, 2 times 2 equals 4. I know that the tangent line has a slope of 4. My normal line is going to be perpendicular to the tangent line. And if you recall, lines that are perpendicular, if you multiply their slopes, their respective slopes by each other, you'll always get negative 1. So, slope of the tangent line is 4. Slope of normal equals negative 1/4. And so now all I need to find is the equation of a line with a slope of negative 1/4 that goes through 2, negative 4. Again, I'm going to solve with slope-intercept form. If you like point-slope form or some of the other ways, you're welcome to do that. I just tend to use slope-intercept form as my default. I'm going to have negative 4 equals negative 1/4 times what? My x-coordinate, which is 2, plus b. Negative 4 equals, well, 2 times negative 1/4 is negative 1/2 plus b. b will equal negative 4 plus 1/2, negative 8/2 plus 1/2. b will equal negative 7/2. What's my normal line equation to this function at the point 2, negative 4? that equation will be y equals negative 1/4 x minus 7/2. Right, let's do another one. Find the equation of the normal to the curve x to the 4th minus 2x squared at the point 2, 8. Same process. Let's do it. F prime of x equals 4x cubed minus 4x. When x equals 2, f prime of 2, the derivative of f of x evaluated at x equals 2 is 4 times 2 cubed, 8, minus 4 times 2, minus 8. 4 times 8 minus 4 times 2, last time I looked, that is 16. What do I know about our line? So let's check again. What do I know about it? I know that I want a normal to a line, the tangent line. Tangent line has a slope of 16. My normal slope equals negative 1/16. What am I supposed to solve now? Well, let's work our way through this very quick and see what happens. I'm going to have 8 equals negative 1/16 times x times 2 plus b. 8 equals, well, negative 2/16, negative 1/8 plus b. That tells me that b equals 8 1/8. And if I want to make that a fraction, I can go ahead and make that 65/8, just for the sake of having a fraction, that's all. You could do 8.125 if that makes you happy. Either way is fine. What's my equation? Y equals negative 1/16 x plus, oops, let me put my x up here. Negative 1/16 times x. I don't want you to think that the x is down in the denominator, so I apologize there. Negative 1/16 times x plus 65/8, and I am solved. All right, one more problem to work our way through. Find equations of all tangent lines having a slope of 5 to the curve 2x cubed minus 3x squared plus 5x plus 4. All tangent lines having a slope of 5. Well, that sounds like take a derivative, which is what? F prime of x equals 6x squared minus 6x plus 5. And I want that derivative to be equal to what? I want to find all values of x where this derivative is equal to 5. So I'm going to have to say 5 equals 6x squared minus 6x plus 5. Subtract 5 from each side. 0 equals 6x squared minus 6x. What can I say from a factoring standpoint? Well, take out a common factor. 6x times x minus 1 equals 0, which means I'd have a solution at x equals 0, where the derivative would be equal to 5. I'd also have the derivative equal to 5 when x is equal to 1. Now, I know my x values where that slope is going to be good. I need to figure out the exact point for each of these x coordinates. When x is equal to 0, f of 0 is equal to 4. 0, 4 exists, and at that point, the slope of the tangent line is equal to 5. So that's one that I'm going to work through. The second that I'm going to work through is when x equals 1. What am I going to have? 2 minus 3 plus 5 plus 4. 2, 5, 4. That's going to add up to 11. Minus 3 is going to equal 8. My other point is 1/8. And the tangent line, when it goes through 1/8, is going to have a slope of 5. So I'll let you finish out the video. All you need to do is develop the equation of a line with a slope of 5 that goes through 0, 4, and the slope 5 through 1/8. Build the equation for that. There are 2 different tangent lines to this curve that will have a slope of 5. And you'll be able to build the equations because you know the points that they go through.